Hello, grade 12s. Let's look at question 4 of the organic reactions extracted from the 2022 question paper that was written in November. Okay. Organic chemistry or organic reactions, one of the simplest segments of organic chemistry. Guys, remember that organic chemistry carries the most marks basically in your question paper, which is the chemistry part of your paper. So the question says the flow diagram below shows how compound A can be used as a starting reactant to prepare two different compounds. And those two different compounds are going to be compound B and also compound C. We are going to produce the two compounds from, compound A. And it's very much important that we study, compound A. So, guys, we need to perhaps draw compound A for us to be able to understand what type of, a compound it is in terms of from which homologous series and also the functional groups and all these other things. So this is how we're going to draw it. I'm going to have it drawn this way. I'm just going to have your C there that is surrounded by your hydrogens. And then I have the next C. And on that C, we've got a C that is surrounded by your hydrogens. And I have, a C surrounded by two hydrogens. I've got the last C that is surrounded by your three hydrogens, and then I'm going to have a Br here. So it means here I'm basically dealing with a haloalkane. And immediately you remember that you're dealing with the haloalkane, you need to quickly think about the reactions that haloalkanes can actually undergo. But then now, looking at reaction 1 there, you can see that we're going to produce an alkene. So producing an alkene, guys, from an alkane, it means, we need to have, double bonds, in between there. And then remember, we're going to use your Markovnikov's rules. And then from here, listen, it means number 1, we're going to have an elimination reaction. Elimination reaction, and the name of the elimination reaction, remember, for us to produce an alkene, it means we are going to remove a hydrogen and also your whatever, what do you call this, your bromine. All right, so now let's look at this question. Is compound A primary or secondary or tertiary? It's going to be a tertiary haloalkane. The reason why it's a tertiary haloalkane simply because the Br is located to the carbon that is located or that is bonded to 1, 2, 3 carbon. That's why it makes it a tertiary alcohol. I mean tertiary haloalkane. So guys, stop saying because your Br is bonded to a carbon that is surrounded. Those carbons are not surrounded, they are bonded to the carbon there. So I should say Br is bonded to a carbon that is bonded to other 3 carbons. That is the language that you're going to use. So it's going to be a tertiary alcohol. Consider reaction 1. Beside heat, write down the other reaction condition needed for us to be able to produce your alkene from the haloalkane. Guys, what is it that we need? We need a strong sodium hydroxide that is concentrated, or you can write it this way: concentrated, a sodium hydroxide, because we know that your sodium hydroxide is basically a strong base. And then even if you write it as conc sodium hydroxide, it means it's basically strong sodium hydroxide which is concentrated. Okay, just to create space, guys, you're going to write it as, you can write it as your your conc sodium hydroxide. 4.2.2, write down the type of reaction that takes place. For number 1, the type of the reaction taking place, guys, is going to be your halogenation. And the question is not so specific. Even if you write your elimination, you're still going to get the right answer, even if you write your elimination there. Wow. Using structural formulae for the organic compounds, write down a balanced equation for the reaction 1 there. Wow, I need more space for this one. Need more space for this one, because you can even tell the number of marks there. It's basically your 5 marks. So, oh, I shouldn't have cancelled, erased it like the first one. So what we're going to do, guys, here, we are going to have this as, because it is the one that is producing that, we're going to have your C, and then make sure that you write your hydrogens there. Okay, so sorry for that. There's a hydrogen there, and then you've got your Br here, and then you've got hydrogens. And how many hydrogens here? You're gonna have it, 3 of them. Guys, I'm going to write the reaction going downward because we don't have enough space. So you're going to have conc sodium hydroxide. Some teachers use lithium hydroxide and potassium hydroxide, and however, all of them are going to be correct. So the first major product that we're going to have, it's going to be an alkene, and we're going to see the movement of your Br. If the Br will, when Br is removed, so the bond will come this side or this other side. So we're going to have it as this, right? Hydrogen, 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 and hydrogen. And then we're going to have your this one, and we have your C that, right? So this is going to be your major product of the alkene. And then number 2, guys, you're going to have plus. Remember, if you are using a sodium hydroxide, this sodium and this Br will sodium Br plus the OH and 1 hydrogen that is removed here will also form water. However, guys, this is when you are using sodium hydroxide, but should you use this one, the product here will be lithium bromide. And then if you use potassium hydroxide, it's going to be potassium and that one. So this is basically, how we're going to be awarded there. Remember, this should be 1 mark, 1, 2, and then 1, 2, 1, 2, 3, and then the reaction conditions and that one. So you get all the full 5 marks, guys. Thank you so much. Just reverse back the video and you will be able to see everything that I wrote on the video there. We are done with 4.2. So let's go for 4.3. So write down the structural formula of compound C. Wow, compound C, we are moving from the alkene into the compound C that contains oxygen there. Obviously, alkene was, a compound B is an alkene, and if you're going to add water to this one, we're going to be able to produce an alkene there. We're going to hydrate and produce your alcohol. H2SO4 should be one of the conditions there. All right, so let's write down that one. We're gonna have it as 1, 2, 3, 4. Remember, this one was that, and the OH will basically attach here. Then we're going to have, this as spaces or bonds for your hydrogen, guys. Please remember, you need to make sure that there's a bond between your hydrogen and also your carbon. This is going to be, the answer for 4.3.1. Let's look at 4.3.2. Name or formula of the inorganic reagent needed. The inorganic reagent that is needed is going to be water. Remember, for you to hydrate and also produce an alcohol, you need water there. The type of addition reaction that takes place is going to be your hydration. It's going to be your hydration, and someone can say no, It is an addition reaction. They are still correct. It's an addition reaction. Consider reaction 3. Write down of the type of reaction that takes place. We're just going to look at reaction 3. We are moving from your compound A, that is a haloalkane, into your alcohol there. So it means we are going to have a substitution reaction. And the name of this substitution could be your hydrolysis. Hydrolysis there. Besides heat, write down the other reaction condition needed. Guys, if we are going to perform a substitution reaction, we are going to use your diluted strong base, or no addition of water. No addition of water is also acceptable there. Okay, guys, thank you so much. That's basically how short this question is. It's a very simple question. Guys, if you need a lesson on organic reactions, please, guys, just contact me on 074-770-0647. I'm telling you, you're not going to regret yourself. I've got more information that will actually boost your confidence and get you more marks. Don't forget to subscribe with us, Blue Star Tutoring Academy. We are based in Pretoria. So if you need help, guys, we're just nearby. Thank you so much and all the best with your matric.